Many consider hydrogen the fuel of the future. This video will review hydrogen and its applications to multiple sectors. If produced and used in a sustainable way, hydrogen can provide a carbonless source of energy. But what is hydrogen? Let's take a look. At the atomic level, hydrogen is just an electron orbiting a proton. What we refer to as hydrogen, H2, is a covalent bond of two hydrogen atoms. This is sometimes called molecular hydrogen. In fact, the first element is fittingly the most abundant in the universe. It's about time we harness it.
Follow along with this video to learn more about how hydrogen is produced and the colors associated with the production methods, a breakdown on fuel cell batteries, the application of hydrogen in industry, and the limitations associated with siting, scalability, and transportation.
There are actually many ways to produce hydrogen. A color system is used to differentiate the method that each color of hydrogen is produced with. Each color produces hydrogen in a unique way, often with differing energy sources, environmental impacts, and costs. The most common hydrogen colors are gray, blue, turquoise, green, pink, and yellow. Gray hydrogen is produced using fossil fuels like coal and natural gas. Green hydrogen uses electricity from renewable energy sources to produce hydrogen via electrolysis. Many of the production methods, like gray hydrogen, still emit carbon as a byproduct, which defeats the purpose of it being a clean energy source. Because of this, it's important to pick methods that are green while still being cost-effective. Electrolysis is a process used by many of the hydrogen colors. It uses an electrolyzer to split water into hydrogen and oxygen.
Now we will discuss hydrogen fuel cells and how they work. The concept is quite simple. If you know how a battery works, you're 90% there. Just like a battery, a hydrogen fuel cell consists of an anode and a cathode to convert chemical energy into electrical energy. Here's how they operate. Hydrogen enters the anode and is diffused across the catalyst that splits the atom. Protons pass through a membrane that electrons cannot. Instead, the electrons flow through an external circuit that generates the current. The electrons recombine with protons and oxygen at the cathode to form water and heat as byproducts. One of the problems facing the adoption of renewable energy generation is that energy demand doesn't always match the available supply. Giant batteries can be the source of this storage, but they are often expensive, require non-renewable materials, and degrade over time. Hydrogen, on the other hand, is a great source of storage. A hydrogen tank coupled with a fuel cell can act just like a battery without the same degradation.
Now that we've touched on how fuel cells work, let's dive into hydrogen's role in industry. The most common place to see hydrogen joining the energy party is in the automobile industry. Just like conventional fuels, hydrogen has been adapted as a fuel in custom internal combustion engines, like you might have in your car now if it runs on gas. Not only that, but as we discussed before, hydrogen fuel cells have also been adapted to power motor vehicles. Although hydrogen can be adapted for the common internal combustion engine, developers faced a multitude of hurdles, like hydrogen's inherent volatility. The hydrogen fuel cell option, however, is a much less stressful to implement. In fact, when compared with several other fuel or engine options, the scientific data supports hydrogen fuel cells as the overall leader. In addition, an industry professional we got the chance to speak with also mentioned that the electric vehicle craze sweeping the nation now can even function as a transition into hydrogen fuel cell vehicles because their engine base is so similar. For as much promise as hydrogen shows in the automobile industry, it's seen some promise in other industries, like the fuel cell outfitting of forklifts in distribution centers or integration into stubborn industries like steel and iron production.
A few aspects of hydrogen implementation that still have some obstacles include siting the hydrogen production, transportation of the produced hydrogen, and the scalability of hydrogen. Choosing a location to produce the hydrogen requires widespread consideration. Attributes to consider include feedstock supply, population density, land use, electric transmission infrastructure, and rail and highway maps. And of course, it is beneficial to choose locations that are more likely to adopt and implement hydrogen. The four main forms of transportation for hydrogen are compressed gas cylinders, cryogenic liquid tankers, pipelines, and blended hydrogen with natural gas. The difficulty with the transportation of hydrogen is that there is a risk of explosion or leakage because of how dense it is and figuring out how to transport it without increased carbon emissions. Touching on scalability, the economy of scale plays a large role in making the use of hydrogen beneficial. This means that large-scale hydrogen production and adoption has the highest economic feasibility.
There's currently no policy in Missouri specific to hydrogen energy. However, the state does have alternative fuel incentives and requirements that include hydrogen fuel cells in vehicles. The U.S. Department of Energy has also put together a clean hydrogen production standard draft.
Hydrogen is still developing, but it's expected that in our lifetime, hydrogen will grow tremendously. It's a slow process, but there's lots of technology developing and research being done for hydrogen, and the outlook is promising.